You said we could read English.
Am I supposed to do everything I have?
If you plug in close to 0, this becomes positive 1, close to 1/2. That's simple. Please.
So anytime there's a vertical asymptote, like in this, the x plus 2 will turn into a vertical asymptote, it's going to be unbounded?
Yeah, vertical asymptote, the limit, you can always say the limit's unbounded. Because the vertical asymptote, that's what a vertical asymptote does, is either on both sides climbs to positive infinity, negative infinity, or splits. So saying the limit's unbounded is fine. And point of encouragement, I guess, I've never seen a vertical asymptote limit question on the MP test. So, anybody else? Awesome, cool. I don't think so. I have to probe my memory a little bit. 17. Other questions here? 17 says, the goal of 17 is to figure out what the value of A should be so that this is a continuous function. All year long, you will see me look at a formula and decide to factor that formula so I can understand better how the formula behaves. So I factor the formula, and I notice I have this special fraction again that is either equal to 1 or undefined. But it's only equal to undefined if x is -3. And according to these instructions, you don't ever use -3 with this formula. So that means for this problem, this is always equal to 1. Which means for this problem, I would rather not use this formula for f. I prefer to use this formula for f because they're the exact same thing. Questions? Not bothering anybody? Shaking your head is very helpful. 2 points per quarter. All right. So now I just start doing some limits over here. So I'm not doing this problem. Whoa, that was exciting. The world's moving. So take the limit from the left, which means I'm using this formula right here. So when x is close to -3, the y value is close to -6. Same from the right. F of -3 would be exactly A. To be continuous, all three of these must be the same, so I found the value of A. Question? 2 from red, and nodding is also helpful. Please.
How did you know that approaching from the right would also be -6?
So I think, okay, I'm close to 3, but just a little more. According to the instructions, unless I'm using x equal exactly 3, the formula I should use to compute the y value is this. So
it would be -3 minus. Okay.
Does that make sense?
Yeah, that makes sense.
Awesome. You pass out some paperwork. You have your calculator, show me. There we go. Raise your hand if having the text message help you remember to bring your calculator. Excellent. So if you haven't signed up for this, I would sign up, otherwise you miss out on extra credits. Here we go. Okay, just so you know what this is. Okay, so today we're going to work with a couple of these graphs.
You gave me two and one was from the...
Oh, my apologies. Stick on my desk. Thanks, Nick. Hey. So don't talk. So we'll be working with a couple of these graphs, and then in the future, these. I gave you the handout just because as you work on the calculator, sometimes it's easy to get lost as to what you're actually looking at because the screen is small. So I'm hoping this helps make sure you don't get confused. This is kind of a sequence of thoughts that I want us to kind of go through. And I thought it would save you a little bit of note taking, so that's all that is. Sometimes this helps, sometimes it doesn't. But. Okay, here we go. So the first thing it says is take two formulas. Formula for the position, formula for the velocity, and plot them on your calculator for this time period, 0 to 0.3 seconds. So do that. You should end up with this exact picture. Go. That's what I was asking. So white. What are we graphing? So just like the instructions say here. So it says use your calculator to plot the position and velocity of the particle. So this is the formula which is going to give us a plot of the particle's position. This is the formula that will give us a plot of the particle's velocity. And we want to see it for this time period. You should get this on your screen. If you don't get that, something's wrong, just ask me, I'll help. Fire is not my friend. Go to window, to the menu.
Keeps turning off.
Window settings. And I said I want to start as directed here. There we go. At 0 on the time scale. X-axis. And I want to stop at 40. Set the window. So let me see on that. Go back to menu. Choose item 4. Oh, zoom fit, which is item 8. This works great if you're good with calculators, but it's because it can do so much, it's more effort to get it to do what you want. For everything we need, that works fine. My favorite actually is 84 color. Oh, wait. This is
So the changing is exponential.
Okay, look up real quick. So one function that a lot of people don't know about that is extremely useful is the following. I know I've got this graph, but I want to go from time equals 0 to time equal 0.3. That's what the handout says. So I hit window. If you have an Inspire, it's the same idea, it's just a different set of menus. But on the 84, you just hit window. Okay, on the calculator, the x-axis is time for what we're graphing. So I want to start at time equals 0, and I want to stop at time equal 0.3. So I only set those two parameters. I don't set anything else because I don't want to mess with it. So let the calculator do the rest. So once you get to there, questions to here? Now hit the zoom key. And I want to choose zoom fit. Unfortunately, zoom, well, it doesn't really matter. Zoom fit is not displayed. So you arrow down patiently, more patiently. So it's 0. So I hate to arrow down that many times, so I just memorize. Zoom fit is zoom 0. I press the 0 key, no enter. The graph will now appear eventually.
Aha, there we go. Wait, I can't keep it.
It's not working. Wait a minute so I can come look.
Oh, wow!
Zoom C.
Wait, no. It's because you can't use the... No. Oh, your letter. You did not think about this. I did not choose to become like if you like this.
I did see wrong. Everybody's trying to see that you said zoom. You and Alex have trouble?
I need to pop a second.
All right. Okay. All of you will want to pay close attention to this. You do not want to be one of the few students. I haven't had very many, but I have had a few students who they didn't tell me what happened, but their friends did. they come back from the AP test and they sadly report that they watched somebody like literally fall apart during the test, like emotionally. Seriously. Because what happened was, they're working in the calculator section of the test and suddenly something doesn't work. Like they cannot get their calculator to function as they have practiced with it. And they can't figure out why. Okay? And the proctors, all they'll do is at best give you a box of tissues. Okay? They won't do anything else. So let me show you a couple of things that most commonly go wrong and how to fix it, so you don't ever panic when you're working with your calculator. So this morning, somebody did this. They were typing in the formula. They got to the end. Okay, they got to here, and they inadvertently pressed arrow. Come on. So it created this. I got two of them. Okay, so get this. Now watch. It doesn't really look like it should cause a problem. But when you hit graph, okay, the key thing to notice is I don't really pay attention to the message. The message never really helps me. Hardly ever. But I do notice that there's a go-to option. And when there's a go-to option, I want to use it. The calculator is pretty good at showing you where the error is. If you press enter, it's highlighting the problem. And then just delete, get rid of it. And then the graph will work. Question. Another thing, watch. Press on, the graph stops. So a lot of times I'll be working on something, and as soon as the graph starts, I'm like, oh shoot, I messed up. I don't want to wait for the graph to finish, so just press on and it'll just stop, and then you can change something. I've also seen people who hand me their calculator, like none of the keys work, it's locked up. Well, all that's happened is they've accidentally started this really long process. If you press on, it will stop and everything works again. Question. Here's another one. I've seen a lot of people do this. They'll be entering items on the y equal menu. They will accidentally turn on the plot. When they hit graph, they get this ornery message, which I don't know what the heck that means. Okay, but there's no go-to, so my go-to is go back to y equal and check for plot. That is the most common mistake. That happens more than anything else I've ever seen. Questions? So just turn it off. If it works for you, what it means is you use some statistical functions, and so the plot is a statistical function, and so it's working, but for most people they never use the stat function, so it doesn't work. So. Cool? One other thing you can do. If none of those things work, or you don't want to mess around, you just want to start over, make sure you don't forget how to reset the calculator. The Inspires have a button on the back. I think the TI-84 Color has a button on the back as well for resetting the RAM. Correct? Is there a button? No? McKay has one.
Oh, yeah. There it is.
So does Porter. Jordan had to find it for me. Look. On the 84, just go second. And then choose the memory key, which is the plus button.
Reset.
You don't, follow what I'm doing, but don't reset your calculator. So press 7. It then gives, what do you want to reset? I want all RAM. And then a final yes or no, and I'm going to choose no for now. If you choose reset, it just puts it back in its default state and everything will work great. So, questions? Superb. Back to the handout. All right, it says, note, velocity is defined as the instantaneous rate of change of position. Okay, other than on a, quiz in this class, you'll never be asked to quote that. but you are expected to understand it to answer AP questions. Velocity is the instantaneous rate at which position changes. That's what velocity means. Somebody, I assume that for years they just would say the instantaneous rate of change of position. And some bright fellow said, hey, I'm sick and tired of saying instantaneous rate of change of position. My last name's velocity, so I'm going to call it velocity. I don't know. So, question? Awesome. It says, what is the velocity of the particle at time equals 0 seconds? 2 ways to do that. A lot of you already know, some don't, so I'll just show. Here's the plot of position and velocity. Remember, a graph is nothing more than a whole bunch of dots, and every dot represents an input and an output. So the horizontal is the time, the vertical is velocity if we're looking at the red graph, position if we're looking at the blue. So I hit trace. I'm supposed to find the velocity at time 0. I look at the formula that's displayed, and note that is the position formula. So that means my cursor is on the position graph. I don't want position, I want velocity. So up, down arrow will move you to this. Up or down, it doesn't really matter. Just press it enough times to get it to move. So here it is. I want to go to time equal 0. The calculator is just waiting. Once you're in the trace mode, type whatever time you want. Press enter. The velocity at time 0 is -1. You would need me to do that again. We were not able to get it to work. Awesome.
What if it says that it's 0?
So that means you're on the wrong graph, because the position at time 0 is 0. So you've got to make sure the cursor is on the correct graph. So you get it right?
How do you get there?
So back here, I make sure I'm in trace mode, and then look at whatever formula is being displayed. And check if that's your velocity formula or your position formula.
And then how do you enter like the?
You get it to work?
Yeah.
Perfect. Anybody else?
Still goes. I went on to the other function and it's still 0.
Hold it to your Let me come watch. Guaranteed to work as soon as I come on. Anybody else? Sweet. Here's one most people don't know. Quiet. Hey. Yeah, don't talk when I talk. From the main screen, you can also find the value of the velocity at time 0 or any time. You'll find this really helpful in the future. So my velocity formula is in the Y2 spot. So I hit alpha, F4, which is the trace key. It will give you a list of all the Y1, Y2 stuff. Choose what you want. I want number 2. Now it's function notation. So I want a parenthesis, times 0, press enter, question. Wait a second.
So is the Y2 for the second equation then?
Right, so in the if in the y equal, you've got y1, y2, y3, etc.
Okay.
And I've got velocity in y2. So remember, when you enter the formulas, you've got y1 is your position formula, y2 is your velocity.
Oh, so you go from the Y screen.
Right.
To the graph.
No worries. So it's not from the Y screen, it's from the main screen.
How do you get there from the main screen?
So on the main screen, are you on the main screen? Do alpha. It says right here F4.
Oh, I see.
Yeah, yours is different. So, there, okay, hey. Just so everyone knows, I mentioned in the disclosure document that the 83 really will do everything you need for this class, but you will have to work harder to accomplish what's necessary. It's like the user interface is just not quite as easy. So if you're going to get a new calculator, I personally would buy an 84 color. You're going to stick with the, or you can rent an 84 color, $20 a year. You're going to stick with the 83, not a big deal, I just have to show you a different method. So you hit variables.
So this is only for the 83?
This is only for the 83. Then you choose Y variables. Then you choose the function variables. And then you have the list. And then the rest of it's the same. They just don't have the shortcut menu. Even out. Cool. Back to the handout. So the velocity of the particle at time equals 0 was -1. The units are meters per second. Find the position at time 0, please. Go. Find the position at time 0 on your calculator. So we found the velocity at time 0. Find the position at time 0.
That's the other graph.
So that's the other graph. Not a very exciting number, but yeah, that's just random. It's not always that. Yeah, you can use the table for sure. Absolutely. The table is also a way you can work it. So. Everybody out? Raise your hand if you figured out successfully that this is supposed to be 0. Show me your hand. Point. Okay, there's a fact you need to memorize. Okay, this particle is moving along an x-axis. So when they say x-axis, don't talk again. When they say x-axis, they're referring to an xy grid, but we're only worried about the x-axis because the particle doesn't move up and down. It only moves back and forth. So here's my x-axis. Here's the y-axis. So this is 0 on that x-axis. That location is known as the origin. You need to memorize the word. They'll use it all the time on the AP test. Now, be careful. A lot of people see the word origin and they think, oh, it's the original spot. No. It has nothing to do with time at all. It's just location 0 on the line. So the particle could be sitting here at time 10. The particle would still be at the origin. The particle could move to the right and then come back and be back here at time 12. The particle is still at the origin at time 12. Has nothing to do with time. Question? Solid? So particles at location 0. This symbol simply means the position of the particle at time 0. Question. Raise your hand if you can tell me. At time equals 0, is the particle moving left or right, and how do you know? Just waiting for you to think about that and tell me if you know how to do that. So at time equals 0, is the particle moving left or right, and what is the indicator that tells you the particle is moving left or right? So talk to each other so everybody knows, because about half of you know and half don't. So talk to each other until everybody knows whether the particle is moving left or right.
It's negative.
Who knows? Show me your hands. Come on, hands up. Who knows? Particle moving left or right? Show me your hand. Particle moving left or right at time equals 0. go, Nathan?
But,
And how do you know?
I just looked at the table and, yeah.
So what, no, stay with me, hey. So what about the data? So you set up your table for what's the time increment?
I don't know.
So what data are you looking at in the table?
On the table, it just has the x equals and then the function, the value of the function at x.
So here's x equals 0. Here's x equal 0.1. Here's x equal 0.2. Here's x equal 0.3. So here's the position function. Here's the velocity data. So point for Nathan, but what about this data is telling you that the particle is going left?
It's going down because it goes from -1 to -1.
No, but you always look at the x. As x goes to the right, it might be decreasing, but that doesn't mean.
Yeah, hold on a minute. Okay, point for Nathan, but hey, everybody, eyes up here. 2 points for Nathan, actually. Put down 3. Whoa. Take 4.
Whoa.
It's to soften the blow. Okay, here we go. Listen. You're awesome. You're awesome. Listen. What just happened is a good example of the fact that in AP Calculus, if you don't know the reason, you won't get the test question right. You just won't. Like I had a student, probably told you the story, he just never wanted to worry about the reason. And as soon as he found out the test was multiple choice, he wanted to worry less about the reason because he was used to driver's ed tests. They're like, you pull up to a crosswalk, a person standing in front of you, what do you do? And the options are like, run them over, honk wildly, swear, wait patiently while they cross. Oh yeah, that was hard. Okay. Hey, 2 points for jokes. Okay. Listen, that's awesome. Hey, quiet. No, seriously, I gave him the multiple choice test. He proceeded to get 4 out of 33 right. I am not kidding. 4 out of 33 right. Okay? You have to know the reasons. You have to know the reason. So the table is awesome. It's a good place to look. Who has a reason for why you know the particle is moving left? Because left is correct. We've got to go. We have to have the reason. Colin.
So like velocity, it can't like technically be negative. So if it's negative, it means it's going in the opposite direction.
I'm going to say it just a little differently than you said it, but you're right on track. So everybody hear this, everybody. Okay, the sign of the velocity, so the velocity can be negative. To this point in your school career, you may have never encountered that, but there's nothing that prevents velocity from being negative. But it means what Colin said. If the particle is going back and forth, the sign of the velocity indicates the direction. So positive velocity means particles moving to the right. Negative means particles moving to the left. If the particle is going up and down, same idea. Up, positive, down, negative. Okay, how many knew it before we talked about it? 2 points. Question. Okay, look at the board. Hey, it's important that you see the other method. Okay? So the red is the velocity, the blue is the position. If I don't have this information, I can still tell you, well, the graph is a little safer because the graph shows the trend. But looking at the graph, I can tell you the position starts at 0. It then becomes something negative, then something more negative. The position is indicating where the particle is at different times. So at time equals 0, here's my particle. Particle is right here. But then a few moments later, the particle has moved to a more negative spot on the line. A few moments later, it's moved to an even more negative spot. That also indicates the leftward motion of the particle. We want to talk more about that. Okay, this handout is not a sample AP test, but the concepts are tested on the AP test in more clever ways. So this is just your introduction to understanding the idea of particle motion, okay? Pretty good? Solid. Next thing. So it was moving left. And this is just, you know, the velocity is negative. That's a valid abbreviation on the AP test, so I'll use it all year long. So the particle's moving left at that time. Questions? Awesome. Please go find, so we already know the velocity at time 0, that's -1. Everybody find the velocity at time 0.1 quick, go. Find the velocity at time 0.1.
Velocities I've seen.
It's one of the best velocities you've seen.
All year. I'm in physics, so I've seen a lot of velocities. Clean, simple.
Show me your hands if you have it, please. Who has it? That's the velocity at time 0.1. Miranda, what do you have?
I have -0.40.
Raise your hand if you can confirm. Show me, come on. 1, 2 from Miranda for being the spokesperson. One other note here. Oh, sir, question.
I know we just talked about this.
You're fine. Let me look. Hey. Hey, big warning again. Look, on the AP test, once you start using your calculator, every calculated answer has to be rounded correctly to 3 or more decimals. So in class, we'll just always round to 3 to practice. If you round incorrectly, or you round to 2 decimals, you don't get the point. Like, they're not linear. You can do everything perfect. If it's rounded wrong, there's no point. Move right on. We good here? Awesome. It says between this time and this time, so on the graph we're looking at about from here to here, is the particle speeding up or slowing down, and how do you know? Raise your hand if you have an answer. So from this time to this time, is the particle speeding up or slowing down, and what's the indication? Like, how do you know that? So if you don't know, talk to somebody who does, so everybody knows. Go.
That was not
Hands up. Who's ready to answer? Come on, show me. Show me. Who's ready to answer? Jock. So is the particle speeding up or slowing down?
Which Josh?
Oh, which Josh? You're right. I always forget it's in line. Far Josh. Fully.
I think it's speeding up.
So tell me why you think it's speeding up.
Because it's getting more popular.
Okay, cool. How many agree that the particle is speeding up? Show me your hand. 2 points for Josh. So the rest think it's slowing down? So who has a reason? Let's go here to Jonathan.
So when the velocity is negative,
the larger the digit itself, the faster it's going, because the negative just means it's going to the left instead of the right. So larger digits will mean it's going faster.
That's a very good explanation. Take 3. Hey, look, no, that's very good. It's really well done. Between you and Adam, you guys come up with a really sweet table over there. Hey, focus, come on, don't talk. What he said is perfect. Right here, the velocity is -1. But as we talked with Collins, the negative just tells you direction. The number tells you speed. So memorize. Velocity and speed are different. They're super related, but they're not the same thing. So right here, the particle's going left 1 meter every second. But as you move along this curve, the velocity is becoming less negative. The negative means the particle's still going to the left, but like Jonathan said, the magnitude, the number is getting less. So the particle's actually slowing. Okay? So how do you knew it was slowing? Give yourself a point. Question? Cool. I would memorize this formula as well. Speed is equal to the absolute value of the velocity. Same thing that Jonathan said, that's just the mathematical way of saying this. I'm not bothered by anything so far. Cool. Okay, next thing. So this just says between this time, the velocity becomes less and less negative. So moment by moment, the particle is moving less and less to the left. Okay, change your window from 0 to 1. Go. Change your window from 0 to 1. So x is our time axis. So yes, we want to change the time from 0 to 1. So the min will be 0. You want to start at 0 and you want to stop at 1. And then zoom fit. So I don't care about the y, I care about the x. So I want to go from time equals 0 to time equal 1. If you're having trouble, this way you don't. It should look like this.
I need to get a new calculator, man.
See, I need to start telling you.
Yeah, I will.
All right. So that works really well.
Yeah, you use it slower.
As long as you use it, you use it.
But like I don't, it's like in the middle, it's like
I don't do as much detail here because I don't know it quite as well. But I can usually walk over and show you. Or like, somebody next to you can show you. I'll show you this. It's been fine. A lot of people.
Where's like
As long as you use it, you'll be fine.
yeah.
Because I don't remember the details. But together, I can use it. All right.
Wait, how does that work? Oh, I see.
Zooming in on that, I guess.
Zooming in on the fish.
Yeah.
You use it yourself. All right, here we go. We know the position at time 0 is 0. Find the position at time 1, please. Go. So just quickly, what's the position at time 1? Who has it? Hands up. Position at 1, Steven. try to catch with a mouthful. Doing my best imitation of a waiter. They always ask you questions when you're. How many have it? Show me. Hey. Point 2 for Stephen. Question? Okay, cool. This means the change in the position. I showed you the change in the position as a formula, and I also have it on the next line as a statement. They're the same. Whoa. I do not know why, but my monitor does that periodically. Does yours do it? Honestly? Seriously?
No, yeah, I'll be playing Fortnite and it was wild, right around about to die.
And then it comes back.
Yeah, but then I'm dead.
So if you can figure out why, I'll be very grateful. I'd like to fix that. If I find out, I'll tell you. Hey. So 9 is the same thing. Look. Yeah, don't talk when I talk. Okay, again, don't just copy the numbers. Make sense of the ideas. Question. Please.
How do you get 3 from -3 minus 0? Oh, okay.
No worries. You're good.
How do you spell BLR?
Kind of like that. Take 3. Take 3. You got 3, please. All right. Hey. No, it's awesome. Okay, you're going to have to memorize this. We've already talked about average rate of change, so this isn't really that new. The average velocity is the average rate of change of the position, or the secant slope of the position. So if I use this formula, it says what is the average velocity of the particle from 0 to 1? The change in the position is -3. We've been doing this on a quiz, so this isn't new. The change in the time is 1 second. So the average rate of change is -3 meters per second. The average velocity is -3 meters per second. If you look here, if you look at the position graph, which is blue, and you draw a secant line like that, the slope of that line will be -3. Because the average rate of change of position is the same as the secant slope of the position.
We just did that with the tables, didn't we?
Right, we've been doing it with tables, but same idea. Question. You need to have that ready. So I gave it to you so you have it. It is interesting to note, we go back to the calculator here, the velocity at time 0 is -1. I need to change my window, 1 second. So I need to go to 1. Zoom fit. So the velocity at time 0 is 1 meter per second. Wait for the very exciting calculator. I don't know who thought it was a good idea to make the plot function slow. It's a tough day when you've got to watch a graph. Hey, velocity at the beginning is -1. 1 second later, the velocity is -10. But on average, the velocity is -3. Does that make sense?
Yes.
Wait.
So the velocity right at time 0 is -1. The velocity right at time 1 is -10. So along the way, the velocity is like less negative, then more negative, more negative, more negative. But on average, the velocity is actually -3. That's what average velocity means. Is that okay?
So you get the average negative because it goes up at the beginning and then down?
Correct.
Okay.
Plus it starts, the average is -3, so it starts at -1, which is not as fast as -3. And then the average just turns out to be -3. Anybody else? Cool? Back to here. Therefore, on average, the particle's position is changing by -3 meters every 1 second. That's how the particle moves. Any questions? Solid. This class is 15 minutes faster than the other two, so.
So 3 tickets, we should just leave 15 minutes early.
No, I can't do that, I get fired.
Hey, gotta
Okay,
wait.
what are we gonna do?
So what we'll do,
Wouldn't they ever fire you?
I would hope not, but
Like
I,
a
but,
legend.
no, because you have a very easy time.
I take points away with that.
Just kidding.
Hey, listen, so I'm gonna walk around and pay everybody for their tally marks, and we'll still have time, so we'll play a music quiz for some more tally marks. Oh, by the way, hey, look up, look up, look up, look up. Just so you know, we're in the middle of working on getting you to understand a big idea, not a little concept, like a big idea. So sometimes that takes a couple of days. And I don't like giving you homework that's not really AP level, per se. So there's no homework tonight. Instead, just make sure you understand this. So if I give you a quiz on Monday, you can do well. So tell me how many tally marks you're owed, and I will count them out for you. 13. Nice. I get tired of counting, so count 13.
We just have to have this by next time for a while. Is this 34?
Correct. With a check mark.
Yeah,
Yeah.
because I only have like 2 more questions.
Over just whatever application you add for.
Yeah. It's 10 per ticket. Yeah.
Yes, cannot.
My tally marks.
That's all great.
I think you're bad at it.
I don't know.
I know, but I thought
Both can't be carried.
Never bring me up in class.
It's like Congress releases Tuesday.